All right, this is LeetCode 1448, count good nodes in a binary tree. So it's also part of the LeetCode 75 interview prep. So given a binary tree root, a node x in the tree is named good if in the path from root to x, there are no nodes with a value greater than x, and it wants you to return the number of good nodes in this tree. This is an oddly worded question, but essentially it means that if you have a path, let's say 3, 4, 5. So if we're currently at the node 5, it's checking if this last node is basically bigger than the maximum in that whole string. So here, the maximum would be 5, which means that that's a good node. So if you start from 3, the current max is 3. If you go to 4, the current max is now 4. Now let's say you go to 1. The current max is still going to be 4. And because 1 is not bigger than the 4, it's not going to count as a good node. So that's just like a weird, oddly worded question. But essentially, I'd say the best way to do this is going through the binary tree, kind of like a depth first search, and basically just going through each node and keeping track of the maximum. So we're going to start this by, I'm going to just create a private method because I think that'll be the easier way to solve it. Because I want to also be able to track the maximum, and we couldn't do that with this base method. So it's going to be, it's going to return an int, an int test. Call this, the max. So this test method is going to go through every branch in the tree, and it's basically going to do that through recursion. So we're going to want to keep track of the count. That's going to start at 0. So from here, we could just we can make sure that the root's not null. So if we do equals null, we're just going to return 0. Does that mean that this root value here, the 3, if that's null, that means that there are no values in the tree. So now we're going to want to check if this current node that we're at, current node root.val, is bigger than this max value, or greater than or equal to the max value. So we do if val is greater than max. If it is, we're going to want to increase the count by 1. And then from here, we're basically just going to want to repeat that for every single tree value. So we're going to want to check left and then right. So we'll do if we want to make sure that node we're going to recurse to isn't null. And if it's not null, we're going to do basically we're going to add it to the count. So we're going to recurse through test. We're going to call test again with the left node, and that's going to return us another integer for all the left values. So if we send in this 1 from the 3, that'll send in all the count for all the nodes after 1, which is going to be 1 here. And we're just going to want to add it to the current count. So we're going to do that. Test dot left. We also need to make sure that the max is increasing. So in this case, since the root.val is greater than or equal to max, we can just set the max to root.val. And then here we're going to pass in that new number. We can also make this look a little cleaner. We do prefix notation. And we're going to just do the same for the right side. And after that, it should just turn us the count. And it should be correct. It should be big O of n, I believe. Yeah, it should be big O of n because we're just checking each node once. So, it's a pretty efficient answer.